All right, so this is a continuation of, oops, didn't want to do that. This is a continuation of Chapter 2 notes, Part 1. So this will be Chapter 2 notes, Part 1.2. Here we go. So we talked about matter and energy, and now we're going to talk about, basically what makes up matter. So matter is made up of pure substances that are called elements, okay? And elements are arranged in a beautiful table that you probably saw in chemistry called the periodic table. And the definition of an element is that it is a unique substance that cannot be broken down into any other substances, okay? But elements are made up of pure atoms of, say, carbon and gold and silver. And I'll let you think, I'm going to ask a question, I'll let you think about it. We actually have some elements that are major contributors to the human body. They actually make up 96% of the human body. I'll let you think about that for a second. So the most common elements in the human body are oxygen and carbon and hydrogen and nitrogen. So they make up, sorry, I'm drawing with my mouse here. They make up 96% of our body, these elements, and then everything else, basically, less than 4% is things like calcium and phosphorus and potassium, which are there in trace elements. So again, all of the elements are listed in a nice table called the periodic table, which increases from 1 to 118. And that is in regards to the number of protons that are found in the atom's nucleus, but we're getting ahead of ourselves. So we have 112 known elements with 100% certainty. There are some that are just merely hypothesized. 92 are naturally occurring. 20 of them are artificially created. And again, elements are composed of building blocks, which are called atoms. So an element can't be broken down into any other substance, but an atom, multiple atoms come together of these elements to make structures. So let's see. So if you're looking at the periodic table and we pull out one element, so we could be looking at something like carbon. And what you would see is the C, which stands for carbon. You probably will see a 6 here, and then you'll see 12 point, I don't know, let's say it's 12.01 or something like that. It's not going to be a whole number. Well, what is this stuff and what does it mean? And we're going to look on that in further slides. So again, atoms are the building blocks of matter, okay? We talked about how an atom is the smallest functioning unit of matter, okay? We can break down atoms into smaller particles that are called subatomic particles, but the atom will actually lose its qualities when it's broken down into its subatomic particles. It can't function, it can't go out and do anything on its own. But we do have 3 different types of subatomic particles that have properties that you need to know about. Again, you probably have heard of them. We've got protons, we've got neutrons, and we've got electrons. Protons have a positive charge and they have a mass of 1 AMU. Neutrons have, you can do a squiggle here, a neutral charge or no charge, and they also have a mass of 1 AMU. Electrons have a straight up negative charge, but they have a negligible mass, so it's nil, it's nothing, because it's insignificant. So again, an atom is the smallest functional unit of matter. They can be broken down into subatomic particles, but the subatomic particles can't go out and do stuff on their own. The atom will lose its qualities. And so there's basically 2 different ideas of atom composition. You've got the planetary model and the orbital model. So if we think of an atom, all right, and I used carbon before, so this would be kind of the center or the nucleus of the carbon atom, and inside of here we would have 6 protons, because that's what that 6 stands for in its atomic number, and we know that there is 6, or are 6 neutrons, excuse me. And then the electrons are hanging out in this area outside of the nucleus. So this right here is the nucleus. I'm just going to abbreviate it NUC. Okay, the nucleus, which has overwhelmingly, positive charge. And then in these orbitals on the outside here exist the electrons. And we know that atoms by nature are neutral molecules. So if there are 6 protons and carbon found in the nucleus, we know that there are going to be 6 electrons found orbiting on the outside of the atom. So again, center of the atom is the nucleus. That's where you're going to find the protons and the neutrons packed together. And then outside, orbiting and spinning and flying around the nucleus, we have these orbitals where the electrons live. And it is the electrons that actually will end up facilitating relationships between other atoms in order to enable bonding to occur. And again, atoms are generally neutral molecules because they have an even number of electrons and protons. When there's loss or gain of electrons, because it's the electrons that can either take a hike or be added onto an atom, that's going to cause ions. So the atoms are different because they have different amounts of subatomic particles. And as I just talked about, the subatomic particles differ in both their mass, their charge, and their location. So if I was going to do a little chart, so let's see here. I've got protons. Oops. Need my little pen back. Where's my little pen? Down here somewhere. Here we go. Pen. It is indeed a little pen. Sorry, I gotta zoom in my page here. So, if I did a little chart here, oh, I don't have to do a chart because it's right here. Okay, we've got protons, and we've got neutrons, and we've got electrons. And you should know the difference between each of them in terms of their mass, their charge, and where they're located. Okay, so protons are positively charged. They have a mass of 1 AMU, which is atomic mass unit, and they're located in the nucleus, or the center of the atom. Neutrons have a neutral charge. They have a mass of 1 AMU, and they're also located in the nucleus. Electrons are negatively charged. Their mass is so small, it's considered negligent. And they're located in these orbitals, or these circles, and we've got different orbits that exist outside of the nucleus, where theoretically this is where these electrons are going to live. But in a normal atomic state, an atom is neutral, meaning that it has an equal number of protons to electrons. And when an atom either loses or gains electrons, it will cause it to have an imbalance of charges, and we're going to call that an ion. Okay, so that's exactly what I just talked about, is that atoms are typically equal. However, when there's a loss or gain of electrons, we're going to call that substance an ion. And depending upon who that atom is, and as you probably learned where they are in the periodic table, atoms really want to work to fill their orbitals. They don't want their orbitals to be empty. And so some atoms are going to bond with other atoms to become more stable, and they're stable because they're becoming fulfilled. They're filling their valence shell, which you may have heard of before. So when an atom loses or gains an electron, okay, it's going to be called a different thing. So when an atom loses an electron, that means that it's going to have more protons than electrons. It's going to become a positive ion. It's going to have a positive charge, and we call that a cation. And I think about you know, I have 4 cats, so that's a positive to me. So that's how I remember that cations are positive, meaning that they have more protons than electrons. When an atom gains an electron, okay, so they're getting more negative charge, they are going to have, you know, an uneven protons versus electrons. They're going to have more electrons, so they're going to have a net negative charge, and this is called an anion. An anion to me sounds like onion, and that's onion breath, and that's kind of a negative. Okay? So electrons, I call them the subatomic players. So they are responsible for facilitating relationships between atoms. So they're zooming around in the orbitals with the whole purpose of trying to find orbital fulfillment, specifically the outer orbital or the valence shell, which you've probably learned before. And depending upon how many electrons they need to either, you know, either to fill up that valence shell, they're either going to give away electrons or they're going to take up electrons to make themselves bonded with another atom to become more stable. And again, looking at, I drew a little structure here, I'll draw it again. So looking at our carbon, okay, so there's 6, and there's probably like 12.1, say, okay? So the atomic number would be this 6 here. So that's in reference to the number of protons. So for carbon, the atomic number would be 6 that an atom has in its nucleus. Atomic mass is the sum of an atom's protons and neutrons. So that's going to be a whole number because we can't have part of a neutron or part of a proton. So for carbon, that's going to be 12. Atomic weight is going to typically be a decimal, okay, because it's basically approximately equal to the mass of its most abundant isotope, okay? And an isotope is going to be atoms that have the same atomic number, okay, but they have a different number of neutrons. And so you'll probably, you know, heard of, oh, that's supposed to be a C. Get rid of that, not a 6. So we've got carbon 12. You might have heard of carbon 14, which is a radioactive isotope, okay? So in carbon 14, these atoms of carbon have 6 protons, all right, but they have 8 neutrons. So meaning that their atomic mass would be 14. So this number right here is an average of, you know, all the different isotopes of carbon. And isotopes are more unstable and are typically known to be radioactive. So as I talked about before, electrons, which are representative E negative, are hanging out in orbitals, and they are responsible for, you know, interacting with other atoms to end up causing, you know, molecules or compounds to occur. And the reason why atoms bond together is to become more stable. And again, electrons are the subatomic players. They cause chemical bonding by either being given away to another atom to create a bond to make more stable, or that other atom then taking those electrons to become more stable. Okay, but the whole goal of bonding, all right, is for atoms to fill their outer orbitals with electrons by either losing or gaining electrons. Speaking of bonds, we've got 3 main types of bonds. There are 2 types of covalent bonds that we're going to be talking about, but that will be the next segment.